Welcome to another deep dive. Today we'll be going way back to the late Cretaceous period. We're going to meet the real Velociraptor. And get this, we'll be ditching all the Hollywood stuff.
You know, it's amazing how much movies and all that shape what we think. Like, picture a Velociraptor, you probably see those big scary guys from, that movie, right?
I know exactly what you mean.
Yeah, but the actual Velociraptor, totally different story. I mean, even just their size.
Okay, I got to ask, how big were these things, really? I'm kind of ready to have my Jurassic Park dreams crushed.
Well, picture a turkey, not a human. That's much closer to the real deal.
Wow, really?
Oh, yeah. Being that small probably helped them hunt, too, They could dart around and go after smaller animals.
That makes a lot of sense, actually. It definitely changes how you picture those big movie scenes.
For sure. And speaking of changing how we see things, let's talk about feathers. You know Velociraptors had feathers, right?
Yeah, the whole feather thing. It's a total game changer. It's crazy how much one discovery can just flip everything we thought we knew.
It really is. So we found these things called quill knobs on a Velociraptor bone. Like bumps, they're proof of feathers.
So not the scaly lizard look from the movies.
Nope, not even close. Now we know they were feathery and way more dynamic. Makes those old reptilian images seem so outdated.
I can't imagine seeing one in person. It'd be wild. And speaking of iconic features,
Yeah.
we got to talk about that claw, right? That big sickle-shaped one on their foot. I mean, that's got to be one of the most recognizable things about a velociraptor.
Oh, absolutely. For years, everyone thought it was for slashing, like a disemboweling weapon, brutal stuff. But now we think it was more like what hawks do.
Wait, really? What do you mean?
So there's this idea called the raptor prey restraint model. Basically, instead of slashing, they'd use the claw to pin their prey down.
Oh, like hold them in place.
Exactly. Then they could go for a precise kill, like a bite to the neck. Way more controlled, way less messy.
That's interesting. But wouldn't it be dangerous trying to pin down, a struggling animal with just one claw?
That's a good point. But remember, we're talking about a creature with some serious strength. Plus, they had teeth, really sharp ones. So the claw was more like a tool to make things easier, not the main weapon.
It's kind of like a multi-tool then, the claw.
Yeah, you could think of it that way. Smart
Yeah.
and efficient, right? And when it comes to hunting, we can't forget that amazing fossil, the fighting dinosaurs one.
Oh, yeah, the one with the velociraptor fighting a protoceratops.
That's the one. It's like a snapshot from millions of years ago. Frozen in time, a velociraptor locked in combat. Amazing proof that they were predators.
Seriously, it blows my mind that we can even see something like that. Could you describe it for the listeners, what we actually see in the fossil?
So picture this, right? The velociraptor, its claw is sunk into the neck of the protoceratops. And get this, the protoceratops looks like it's biting back, trying to defend itself. It's a crazy scene.
It's almost like watching a nature documentary, but from millions of years ago.
It really is. And this fossil also tells us about where velociraptors lived, because it was found in this place called the Jodocta Formation. And that area, well, it wasn't anything like what you see in movies.
Oh, really? So no rainforest for velociraptors?
More like a desert, super dry, scorching hot. Not exactly the lush jungles people usually picture with dinosaurs.
Wow, a desert. That's a totally different picture.
Right. It makes you think about how they hunted, what they ate, even how their bodies adapted to that harsh environment. And that's where it gets even more interesting. Because they've found shed velociraptor teeth right near a protoceratops jaw, and there are bite marks on it.
Wait, you're saying they might have been scavengers too, not just hunters?
It definitely seems possible. Like if there was a free meal just lying around, why not? Right, they were probably opportunistic. Actually, they even found pterosaur bones in the stomach of one velociraptor fossil.
Hold on, flying reptiles. So their diet was way broader than we thought.
Definitely more diverse than just the usual prey animals. This adaptability probably helped them a lot in tough environments.
This is blowing my mind, honestly.
Yeah.
I always thought they were these super specialized hunters.
It's always more complicated than it seems, right? And speaking of complicated, there's the whole pack hunting thing, like how they show it in movies, working together like wolves.
Yeah, everyone loves the idea of velociraptors as these super coordinated pack hunters. But is it actually true?
Well, honestly, we don't have the proof for that specifically with velociraptors, at least not yet. There are some clues, though.
Okay, what kind of clues?
In China, they found these fossilized footprints called trackways, and they suggest that some of Velociraptor's relatives, the dromaeosaurids, might have moved in groups.
So Maybe not pack hunting, but at least hanging out together.
Yeah, exactly. It's an open question, and paleontologists are definitely still digging into it.
Well, I'm already hooked. It seems like every new detail just makes these creatures even more fascinating.
Oh, we're just getting started. Wait till you hear about their bite force and what we can learn from comparing them to a very unexpected modern bird.
So we're talking agility, speed, all that. But what about strength? Like, how strong were velociraptors, really?
Well, there's been some really cool research on their bite force, Gives us a good idea of how powerful they were.
Oh, so they weren't just quick. They could bite hard, too. Tell me more about that.
Yeah, so scientists have been looking at their skulls, like velociraptors and their relatives. They're studying the shape, how it all works, to see how much force they could put behind a bite.
And what have they found?
Well, it's pretty amazing, actually. Even though their skulls weren't that big, they were built to handle a lot of stress. Like, they could bite way harder than you'd think for their size.
Wow, that's surprising. So what does a strong bite tell us about them? Like, how did they use that?
Think about it. A strong bite is good for both hunting and scavenging, right?
Okay, yeah, I see where you're going.
So picture them using that claw technique we talked about, pinning down their prey. A strong bite would mean a quick, clean kill. No need to mess around.
Makes sense. Less struggle, less risk for the velociraptor, too, right?
Exactly. And think about scavenging. Sometimes you find a carcass that's already been picked at, or it's got tough skin, tough bones. You need a powerful bite to get through all that.
Like to get to the good stuff, the marrow and all that.
Yeah, precisely. So that strong bite, it was a versatile tool, useful for both hunting and scavenging. It helped them thrive in their environment.
It's almost like a superpower. Okay, so we've talked about their physical stuff, but what about their senses? Like, how good was their vision, hearing, smell?
Well, fossils don't always preserve those soft parts, eyes, ears, all that, but we can make some educated guesses based on their skulls and comparing them to animals today, like birds and reptiles.
What do we think they were good at?
Their eye sockets tell us a lot. Like the size and where they're placed, it all points to excellent binocular vision. They could judge distances really well.
Oh, like how we use both our eyes to see depth. That's got to be crucial for a predator.
Oh, yeah, super important for hunting, especially if you're going after fast prey or you're in tricky terrain.
What about smell? I'd imagine being able to sniff out prey or even carrion would be super useful in a desert.
You're right on the money. Their nasal passages suggest they had a really good sense of smell. Perfect for finding food, whether it's alive or, not so much.
And maybe even communicating, like some animals do with scent.
Could be, yeah. Marking their territory, sending signals, it all fits. So yeah, their senses were sharp. Definitely built for a predator's life.
This is all so fascinating. We've touched on their social side too. The possibility that they weren't totally solitary. What else do we have to back that up besides those footprints in China?
Right, the trackways. Well, we can look at their relatives, the dromaeosaurids, and modern birds too. They're descendants after all. There have been dromaeosaurid fossils found close together, which suggests they might have lived in groups or at least hung out sometimes.
So maybe not pack hunting, but not total loners either.
Yeah, it's a puzzle. And if you think about birds today, so many of them are social, right? Flocks, nests, all those complex behaviors. It wouldn't be too surprising if velociraptors had some kind of social structure too.
That's a cool thought. They weren't just mindless killing machines.
Exactly. And then there's the big question, the one everyone always asks about dinosaurs. Were they warm-blooded or cold-blooded?
Yeah, that's a classic. So what about velociraptors? More like reptiles or more like birds?
It's a tough one, honestly. For a long time, everyone thought dinosaurs were cold-blooded, like lizards. But we're learning more all the time, and things have changed, especially when it comes to theropods, the group Velociraptor belongs to.
Okay, so what do we think now? Were they warm-blooded?
Well, a lot of the evidence points that way. Like, remember those feathers?
Yeah, of course.
Well, feathers are amazing insulators. They help animals keep their body heat. So it seems like velociraptors could regulate their temperature better than cold-blooded reptiles.
So their feathers are like a clue to their metabolism. That's amazing.
It is. And their bones tell a similar story. Warm-blooded animals tend to have bones that are more porous, which means they grew quickly and had a higher metabolism. Velociraptor bones show some of those signs.
So they weren't slow and sluggish like we often imagine.
Not at all. More like active, energetic predators, always on the move. Definitely fits with a warm-blooded metabolism.
I love how much we can figure out just from their fossils. It's like detective work.
It really is. And to understand their metabolism even better, we can look at a modern animal, a bird that's surprisingly similar to velociraptors and their relatives.
Oh, really? Which bird? I'm intrigued.
Think of a kiwi, that flightless bird from New Zealand. Might seem like a strange comparison, but they share some key features with dromaeosaurids, like their bones, feathers, even their nasal passages.
So even though they look totally different, there's a connection there.
Exactly. And here's the thing. Kiwis are super active even though they don't fly. Their body temperature is stable, but their metabolism is kind of in between. Not as high as most birds and mammals, but not as low as reptiles.
Like a middle ground. Not fully warm-blooded, but not cold-blooded either.
You got it. And that makes them super interesting for studying how primitive birds and dromaeosaurids functioned, including Velociraptor.
Just like a window into the past.
Absolutely. We can use living animals to understand extinct ones. It's a cool way to connect the dots.
So if we're using the kiwi as a model, does that mean velociraptors were like super energetic, but maybe not as much as birds that fly?
That's the idea. It gives us a more realistic picture, helps us see how they might have lived their lives, how they interacted with their environment, hunted their prey.
This is all just blowing my mind. It's like a whole new way of seeing these creatures.
It's amazing what we can learn when we start making these comparisons, finding links between animals that lived millions of years apart.
Definitely makes you appreciate the diversity of life and how everything's connected.
Yep.
Wow, we've covered a ton about velociraptors today. Everything from like their size to their feathers to how they hunted. It's so clear now. These were some seriously cool creatures, way more complex than I ever imagined.
Totally. And you know what always gets me? Thinking about their individual lives, like what was it actually like to be a velociraptor, you know?
Yeah, what were their lives like? What did they have to deal with?
That's where paleopathology comes in. It's basically the study of injuries and diseases in fossils, like a medical history, but for extinct animals.
So like dinosaur doctors looking at old bones for clues.
Kinda, yeah. And for velociraptors, it's given us some pretty amazing insights. Remember that skull we were talking about before? The one with those puncture marks? Probably from another velociraptor.
You mean the one that maybe showed them fighting each other?
Exactly. And the thing is, those wounds didn't look healed, which means that Velociraptor might have actually died from those injuries. Maybe a fight over territory or food, who knows. But it's a reminder that even though they were top predators, life was still tough.
Totally. They weren't invincible.
Not at all. And there's other evidence, too. One Velociraptor fossil, it had a healed broken rib.
Ouch, a broken rib. That must have been rough.
Seriously. But the cool thing is, it healed. Meaning this Velociraptor got hurt pretty badly, but it survived, it recovered, and kept going.
It's amazing that we can see those details, it makes them seem so much more real. Not just skeletons in a museum, but animals that lived and breathed and felt pain.
Exactly. It helps us understand their struggles and triumphs on a totally different level.
So even in fossils, we can find stories about individual animals. That's pretty powerful.
Absolutely. It adds so much depth to our understanding.
Well, I think we've covered just about everything on velociraptors today. It's been an awesome journey, wouldn't you say?
Seriously, it's been amazing. We started with those, kind of inaccurate movie images, and now we have this much richer picture of what they were really like.
And it shows how cool paleontology is. Every new fossil, every discovery, it adds another piece to the puzzle. So if you had to pick a few things, what would you say are the biggest differences between the real velociraptor and how we usually see them?
Well, first off, the size. They weren't those huge monsters from the movies. Think turkey-sized, not human-sized. And then there's the feathers. They weren't scaly lizards, but feathery dinosaurs. Much closer to birds than reptiles, really.
And the way they hunted, too. That raptor-prey restraint idea. They were more strategic, more precise, not just slashing wildly.
Exactly. And while the pack hunting thing is still up for debate, we know they were likely very adaptable. Their diet, their potential social behavior, even their metabolism, all of that points to a really successful predator.
It's honestly mind-blowing how much our understanding has changed.
Right. And there's still so much more to learn. Every new fossil could change everything. That's what makes paleontology so exciting.
So to everyone listening, the next time you see a velociraptor, whether it's in a movie or a book or even a museum, remember there's always more to the story. Don't be afraid to dig deeper, ask questions, and see what the science tells us.
Because sometimes the truth is even more amazing than fiction. And the more we learn, the more we realize how much there still is to discover.
Well said. It's been a blast exploring the world of Velociraptor with you today, and we hope you've enjoyed the journey as much as we have.
Thanks for joining us, and until next time, keep exploring and keep being curious about the world around us, both past and present.